Okay, so this is the do now from yesterday, April the 15th. In addition to the do now, there's a series of other equations in here that involve fractions. So what I'm going to do is go in detail, try to really explain, try to make sure that you have a clarity and understanding about what's happening here when I'm working with equations that have fractions. Fast forward it, rewind it, pause it. If you still don't understand, reach out to me, okay? But hopefully this video will give you a really good understanding, all right? So let's take a look here. We have our first equation. We have 10 minus v over 4. So in a sense, we have a fraction, okay? I know you're like, wait a second. Strange looking fraction, but fraction, okay? And it says equals 2 times the quantity of v plus 17. Tools here. Let's go through the process. So as you can look here, I have my letters already laid out for my little equation here. So it says letter D first, and that says I will find a multiple of the denominator and use that multiple to turn all fraction numbers into whole numbers. Well, we're in luck. There's only one fraction number. And let's take a look at the denominator. It's 4. So guess what's going to be my LCM in this situation? It's going to be 4. So I go over and I do 4. I do all my work and it magically turns into 10 minus v. What? How did that happen? Okay, exactly. So I know a few of you would be kind of confused. So let's go ahead and go over this process, how this comes from all this kind of craziness here and turns into just 10 minus v, okay? So let's go here. Take this work, bring it a little further over here. So then, remember, 10 minus v over 4 is really in a sense a fraction. Okay, now I can't separate it, or I can't take out any factors over here and make this smaller because the 10 minus v is sort of like one term together in the situation, all right? So I have 10 minus v over 4. Well, with the 4 here, I can change any whole number, like 4, into a fraction by simply putting a 1 underneath it. Huh? How does that work? Take a look. How many sets of 1 are in 4? 4. Turn 4 into a fraction. How many sets of 1 are in 4? 4. Turn 4 into a fraction. How many sets of 4? Are you getting the idea here now? So that's the reason why we can do that. So go ahead and erase this. So now we recognize, hey, 4, turn to a fraction number. And then I have, okay, where did that 1/4 come from? Remember, 4, I just went ahead and snatched that 4 away. And so notice, I cancel out. Well, mister, you got 1 over 1 here. Okay, so 1 over 1. Well, how many sets of 1 are in 1? 1. So that's the reason why, in a sense, when we get that, we just cancel it out. So let's go ahead and show you this. So I have 4 over 1 times 10 minus v over 4. Cancel out. Result 10 minus v over 1. How many sets of 1 in that entire thing? That entire thing. Thus, 10 minus v, our resulting answer right there. Pause this, rewind it if you need to understand how I went from this expression here to that one, okay? So let's erase. So we know the rule is that if we apply, an action to one side of the equation, we must do it onto the other. So notice I multiply every term on this side, this section here, by 4. I must do the same thing here. Now this is something very interesting because with this 4, I've already sort of got like something happening. Let me erase this. I already got 2 times v plus 17. But then you say, Mr. Eve, you got to do 4 times that. Well, which one do I do? How do I work it out? Well, in a sense, it really doesn't matter here. It's sort of like a community property. So let's take a look here. Let's do it the Mr. Heath way. I'm going to go ahead and go 4 times 2. So let's erase that. So I'll go here. I'm going to do 4 times 2 first. 4 times 2, I get 8. And I bring this down, apply my distributive property, my smart cut. Invisible uno. So apply my distributive property here. When that's done, I get 8v plus 136. Cool. So let's go here. Mr. What if I apply distributive property first and then multiply by the 4? Let's take a look and see here. So I'm going to leave the 4 just over here for right now, waiting. And then I have 2 times the quantity of v plus 17. Invisible uno. Separate smart cut. Let's go. 2 sets of 1, 2. Drag the v with it. Done. It's positive, so that's cool. And then 2 sets of 17, 34. So now let's take that 4 and multiply it across. Smart cut. 2 sets of 4, 8. Positive. 4 sets of 134, 136. So we notice that either way, we're going to get that same answer, okay? So whatever works for you. I just tend to do it this way, then apply distributive property, but you could do it that way. It wouldn't matter as well. All right, let's erase this. So we've done all that work up there, okay? That was D, applying the LCM. Let's go ahead, and since I'm doing it my way, I'm going to go ahead and do C and apply distributive property. So smart cut, or invisible. Go over here. We know from early in the video that 1 set of 8 is 8. That's right there. And then here, as opposed to 4, because you remember with the 2, it's 8 sets of that. 8 sets of 17 gives us 136. All right. So now I'm down to 10 minus v equals 8v plus 136. I need a letter A. I need an inverse operation. Looks like I'm decided that I'm going to have variables on the left-hand side, and I'm going to have numbers, constants, integers, how you want to see that, on the right-hand side. So because of that, let's go ahead and start getting rid of the numbers on this side. So I have 10 positives here, and if I was on the number line and I had 10 negatives, I would get back to 0. If I use an arithmetic, 10 minus 10, 0. What I do on one side of the equal sign, I must do it on the opposite side or the other side, however you see that. So that was 10 negatives there, bring those 10 negatives over here. If you want to use arithmetic, 136 minus 10 is 126. If you're using integers, 136 positives, 10 negatives leaves you with 126 positives. So I'm looking pretty good. I got my variable over here. Oh no, there's still a variable over here still. Okay, so it looks like only my numbers are set. Let's get the variable over to the left-hand side. So 8 positives on the number line, 8 negatives gets me to 0. Arithmetic, 8 minus 8 leaves me with nothing. Remember, what I do on one side, I do on the other over here. So that invisible uno there, because that's going to be important so you guys don't make a mistake. You see, this is 8. So I have, or negative 8. So I have 1 negative. I have 8 more negatives. I have a total of 9 negatives. That's important to see there. Okay. Once again, that was inverse operation. But notice, as opposed to inverse operation involving constants or integers or numbers, however you want to say that or see that, in this one, it was the inverse operation involving variables. Okay. So let's slide this down. Let me erase this. Slide this down some. Okay. And then let's finish it out. Okay. So then we have E, F, B, baby. It's time to go ahead and find the quotient. So notice what I'm going to do is divide the coefficient by itself. I call it the eyeball check. So what's the coefficient here? Negative 9. All right. So now divide negative 9 by negative 9. Of course, that gives me that positive invisible uno. What I do on one side, I'm going to do the other. Hey, I got 1 negative. That's odd. So therefore, negative. I'm going to do a wind up. How many sets of 9 are in 126? 14. Final answer is V equals negative 14. So that's your solution for that challenge from the do now from the 15th. All right, let's go and clear this out. Let's go ahead and look at some other stuff. Oh, hey, real quick, I did want to talk about this one here. When we look at the LCM here, I'm talking about positive. I want you to take note of it because when we are trying to get rid of that fraction in the denominator there, we want to make sure that if it's positive, we want to use a positive number like positive 4 here. If it's negative, you use a negative number. So you see examples of this, but just keep that in mind. So my LCM I used was a positive number. Let's go on to the next one here. So we have this next equation here where it is a fraction. So let me go ahead and get my little. So notice we got one fraction here. So n over 7 minus 12, or some number over 7 minus 12 equals 5 times some number plus 5. So really, once again, we do have that LCM situation, letter D, but once again, we have only one fraction and one number in the denominator. So let's go ahead and, excuse me, let's go ahead and clear that up. Erase. So what's going to be our LCM? You got it, 7. Now we talked about applying distributive property here with these numbers. Let's talk about this situation because that can look intimidating once again. So notice I have 7 times the quantity of n over 7 minus 12. But then from all that craziness, I get this. So let's once again take this, bring it over. Let's have a little discussion about it, okay? So if you were to notice, if I do a smart cut here and I was apply this out, it'd be 7. Remember, let's change 7 into a fraction number so we can have comparable numbers. Times 1 over 7 n. Mr. Heath, that doesn't look like that. It looks like this. I got you. But remember, what's in front of that n? An invisible uno. So I could go 1 over 7 n. I think that doing this way makes it easier for you to understand the idea that, oh, that's why I can do, 7 over this and cancel it out. So notice, my n separated right now. I mean, it's still, hugged up in a sense, but it's not like this that can be very confusing. So notice, cancel out. And for those of you guys that kind of throws you out the fractions, notice here, let's get one big bar. And notice, they got the 7 in common. Well, they got that 1 in common. Well, when we divide 1 into 1, it turns into what? 1. So that's the reason why all of a sudden I can cancel this out. That leaves me just with the n. So notice the n right here. And then I'm going to go ahead and multiply. Oh, wait, I have an odd negative 1. So make sure I put my negative there. And 7 sets of 12, 84. So go back, rewind. If you're still confused, reach out to me. But I just want to make sure you understand that thinking about how can it be so crazy looking over here and all of a sudden just be just that. All right, so let's kill that out. So I'm going to go ahead and apply distributive property. So notice I did sort of like a DC thing here where I did the LCM in a sense, but also apply distributive property at the same time. So wait, let me do a smart cut. So first apply there, and then go here. So you can notice 7 sets of 5, 35. Okay. 7 sets of 5, 35. Oh, don't forget to bring the n as well. So now I have n minus 84 equals 35n plus 35. Looks like I want the variable on the right-hand side this time, and the numbers, the constants, the integers, I want to see that on the left-hand side. So let's go ahead and start getting the variables over here. So I have a variable on the left-hand side, so let's push that over. If I want to go ahead and remove that n, I have 1 negative, the 1 positive on the number line gives me the 0. Or with arithmetic, 1 minus 1, nothing. What I do on one side, I do on the other. Don't forget your invisible uno there. So then you notice I have 35 positives and I have 1 negative. Gives me 34 positives. If you're thinking with arithmetic, 35 minus 1 gives you 34. And you bring down the n there. So then I didn't do anything to this constant here, 35. So I just bring that down. As you can see, I have negative 84 equals 34n plus 35. Well, I still got to go ahead and get that number over there. Remember numbers on the left-hand side and variables on the right. So add 35 positives. I'm going to hit with 35 negatives on the number line. That would give me the 0. If you think arithmetic, 35 minus 35 gives you nothing. What I do on one side, I'm going to do on the other. So I take my 35 negatives over here. I combine it with my 84 negatives. It gives me 119 negatives. So my 34n, I didn't touch it. So I bring it down here. All right, FB baby time. So what's my coefficient? 34. Eyeball check, 34. So I divide by the coefficient. 34 divided by 34 gives me my invisible uno. And then I go over here and I have my negatives when I find the quotient. So negative. I do a wind up and do the computation. 3 and 5/10. All right, so the value, that's a bad looking 5, but you get the idea. So the value of, in this situation, is negative 3 and 5/10. And notice, what was the LCM in this one? Since it was positive, the LCM was going to be positive that I used to remove number from the denominator. All right, so let's go here. So notice, LCM positive. Let's go on to the next challenge here. This one looks very, very, very intimidating. And it can be, but if we go ahead and use the D letter in terms of using the least common multiple to cancel out the fractions, we can go and change them to whole numbers and finish this up relatively easy. All right, so first things first, let me get my writing instrument. So let's take a look here. So I have negative 5/6 times the quantity of 8 plus 5b equals 75 plus 5/3 b. Whew, that's a lot. So it can be very intimidating. So I look here. I go, okay, I got two fractions. I got one in there. I got one here. One negative, one positive. All right. So denominator 6, denominator 3. Let me lay out and find the smallest number both of these can squeeze into. All right. So 1 times 3 is 3. 2 times 3 is 6. Wait a second, 6. Hey, well, one set of 6 is 6. I think we found a number that they both share, the smallest one as well, okay? So it looks like 6 is going to be the LCM we use here. And notice that is the LCM that's being used here. Notice that's what's being used here. All right, so I'm going to go and erase this. Now we know we got that 6. So let's go ahead and apply the 6. Once again, I'm going to multiply this by this and then leave this alone. Okay, we learned from early in the video by which way we can go ahead and actually multiply. I'm going to stick with the way I do. So if I go over here, I have 6 as a whole number times negative, terrible 5, negative 5/6. Okay, so I'm going to clear this out and do a better one here. So let's erase this out. Erase. All right, so 6 times 5/6. I'm going to leave the negative down here because we already know the answer is going to be negative. But I have a choice to make, right? I have a negative fraction here and a positive fraction here. I can use a negative 6 or I use a positive 6. So in this situation, I'm going to use a positive 6. So I'll go over here and I'm going to have 6 over 1, because remember, we can change the whole number into a fraction. 6 over 1, I'm going to go times negative 5/6. You can already see what I can do here. Cancel out. That leaves me negative 5/1. If I do a wind up, how many sets of 1 are in 5? 5. And how many negatives were there? An odd amount? Negative. So this negative 5 that I have here is what you see here. This is the process that took me from all of that to this. All right, so let's go ahead and clear this out. So clear this out. Erase. All right, so let's continue on. I'm going to push this up some so we can see some more. All right, so I've done all that hard work. That puts me in a situation where I'm going to use letter C, apply distributive property here. So let's apply distributive property. Smart cut, so I don't think I'm trying to combine or add or anything like that. And apply. Go here and apply. All right, so I have an odd amount of negatives, so 1, so negative. And then 8 sets of 5 is going to give you 40. Done with that. Notice 1 negative here. Oh, I got an odd amount of negatives, so 1 negative there. 5 sets of 5, 25. Drag the B down. There you have it, okay? So then I'm going to bring down my 450 plus 10 B because I didn't do anything at all to it. They're not like terms. I can't combine them, so let's bring them down. So in this situation now, I have negative 40 minus 25B equals 450 plus 10B. I've decided that I want the variables where? On the left-hand side. I want the numbers where? On the right-hand side. So let me go ahead and start positioning these variables where they need to be. So I see a variable on this side, so let's get rid of it. I have 10B. Well, if I'm on positive 10 on the number line and I get 10 negatives, it gets me to 0. If you're doing arithmetic, 10 minus 10, nothing. What I do on one side of the equal sign, I'm going to do on the opposite or the other side if you see that. So that was 10 negatives, I'll bring them over there. I already had 25 negatives, and now I have 10 more negatives, that gives me 35 negatives, okay? And I'm going to bring down my negative 40 because I didn't do anything to it. All right, so now I have negative 40 minus 35b equals 450. I said that I wanted the variables where? On this side, and I wanted the numbers on this side. So the variable's looking good, but I got a number here. So 40 negatives, give me 40 positives on the number line, gives me the 0. With arithmetic, 40 minus 40 gives me nothing. What I do on one side of the equal sign, I do on the other. And so now I have 450 positives, and I have 40 positives. That gives me 490 positives, or if you use arithmetic, 450 plus 40 gives you 490. Well, it's time for FB, baby. All right, so we have negative 35 is the coefficient in front of the B, so eyeball check. I see negative 35 here. I'm going to divide by negative 35. That's going to give me my positive invisibile uno 1. What I do on one side, I got to do on the other. So I divide by negative 35. Hey, an odd amount of negatives. Negative. How many sets of 35 are in 490? 14. Final answer, negative 14. So go over these equations, look them over, rewind, practice, and use them when you're facing other equations with fractions to help you out. I will be creating another video as well, so be prepared for that one.